Hello, everyone. Imagine that thousands of items go through the assembly line every second. How are the QR codes, barcodes, and characters on them quickly recognized? In fact, behind these seemingly simple patterns lie the core principles that enable machines to understand the world. In this lesson, we will unveil the mystery of these three identification technologies and explore how they empower the efficient operation of modern industry. Now, let's decode the scientific code of intelligent identification together. This lesson primarily covers the following topics. Through this lesson, we aim to achieve the following objectives. Now, let's learn the first knowledge point, the principle of QR code recognition. QR code is a black and white figure distributed on a plane with specific geometric figures according to rules, and mainly records data symbol information. When the QR code is scanned, the light source of the device illuminates the QR code. The black and white bars reflect and absorb light to different degrees. The reflected light is converted into an electrical signal by a photoelectric conversion device and then converted into a digital signal by a signal conditioning circuit. Then, the decoding software processes the digital signal and parses the information stored in it, such as text, URL, instructions, etc., according to the encoding rules of QR code, such as the standard algorithm of QR code. QR codes are divided into stacked QR codes and matrix QR codes. The coding principle of stacked QR code is that on the basis of establishing linear barcode, it is stacked into 2 or more lines as needed. Matrix QR code is encoded in a rectangular space by different distributions of black and white pixels in the matrix. The typical stacked QR codes include code 16K, code 49, PDF 417, etc. Code 16K can encode numbers, letters, and some special characters. It has high information density and error correction ability. It is often used in logistics, warehousing, and other scenarios that have high requirement for information storage and identification. Code 49 can encode multiple character sets, can store more information in a smaller space, has a certain ability to correct errors, suits for industrial production, medical care, and other fields. PDF 417 can encode all ASCII character sets, including text, number, and binary data. It has extremely high information capacity and powerful hierarchical error correction ability. Its unique, portable data file feature makes it widely used in scenarios where large amounts of data need to be stored. Typical matrix QR codes include QR code, data matrix, maxi code, Aztec code, Barcode, etc. QR code. It is the most widely used QR code system in the world. It supports high-capacity data storage, has strong fault tolerance, and has fast direction recognition function. It is usually used in scenarios such as mobile payment, product traceability, electronic ticketing, and information storage, and has strong popularity and compatibility. Data matrix adopts a compact matrix structure and supports efficient encoding of small data. Its core advantages are ultra-small size recognition capabilities, can be as small as 2 by 2 millimeters, and anti-deformation characteristics, relying on L-shaped positioning edges and black and white dots matrix distribution. It is mainly used in industrial parts identification, medical device traceability, electronic component labels, and other tiny space marking fields. Maxi code, mainly used in logistics and express delivery industries. It can encode a large amount of information, can be read quickly, and requires high printing accuracy. Commonly used for tracking and identification of packages, letters, etc. Aztec code. It has large information capacity and can encode numbers, letters, and binary data. It is characterized by the ability to adjust the size and shape of the code according to the needs, and strong ability to resist defacing and distortion. It is commonly used in industrial control, aerospace, and other fields. Barcode has high error correction capabilities and security. It can effectively prevent the QR code from being tampered with and forged. It can be used in identification, ticketing management, and other fields. After understanding the principle of QR code recognition, let's go on to learn the principle of barcode recognition. A barcode consists of a set of regularly arranged bars, spaces, and their corresponding characters, which are used to represent certain information. The scanner emits light to illuminate the barcode. The reflectivity of the bar and the space is different. The reflected light is converted into an electrical signal by the photoelectric sensor. The intensity of the signal corresponds to the width of the bar and the space. The electrical signal is then amplified, filtered, and so on to become a digital pulse signal. Finally, the decoder translates the digital pulse signal into corresponding numbers, letters, or other character information according to the coding rules of the barcode, such as EN13 code, UPC code, etc. Common barcodes are the following. EN13 barcode, an international commodity barcode consisting of 13 digits. The first 2 to 3 digits are the country or region code. The middle 4 digits are the manufacturer identification code. The next 5 digits are the product item code, and the last digit is the check code. Commonly used on retail goods, such as supermarket goods packaging. UPCA barcode, used primarily in the United States and Canada. It consists of 12 digits. The first digit from the left is the system character. The middle 5 digits are the manufacturer code. The next 5 digits are the product code, and the last digit is the check code. It is common in retail scenarios such as supermarkets. Code 39 barcode can encode numbers, capital letters, and some special characters. It allows spaces to appear in barcodes, has certain self-checking function, and does not require high printing accuracy. Commonly used in industrial production, book management, logistics tracking, etc. Code 128 barcode can encode all 128 ASCII characters. High encoding density and large information capacity. It is widely used in industrial automation, warehouse management, transportation, and other scenarios that have high requirement for information storage and accuracy. ITF-14 barcode. It is a continuous, fixed-length, two-way barcode that has self-verification function, and both bars and spaces represent information. It is mainly used to identify non-retail goods, such as marking boxes and pallets of goods in the process of logistics and distribution. Finally, let's learn the principle of character recognition. One, preprocessing. Carry out graying, binarizing, noise reduction, till correction, and other operations on images containing characters to improve image quality and make characters more legible. 2. Feature extraction. Extract character features such as stroke endpoints, intersections, outline shapes, stroke widths, etc. It allows more advanced feature extraction methods, such as statistic-based features, such as gray-level co-occurrence matrix features, or deep learning-based features, such as features extracted by convolutional neural networks. 3. Classification and identification. The extracted character features are matched with a predefined character template or a classification model trained by machine learning. Traditional methods include template matching, statistical classifiers such as support vector machine, etc. Modern methods mostly use deep learning models such as convolutional neural networks, CNNs. Train the models through a large amount of labeled data to make them able to automatically learn the feature patterns of characters, thereby accurately identifying the categories of characters. Alright, this lesson ends here. Today, we unveiled the mystery of QR code, barcode, and character recognition technology, and decoded the core principles of machine understanding the world. They are like the eyes of wisdom on the industrial assembly line, driving the efficient operation of modern production. In the future, how will these intelligent identification technologies be more deeply integrated into life and reshape the industry? The answer lies in our further exploration. Thank you for learning. See you next time.